They want to know what is the interval of increase and decrease for this function. Well, to be able to do that, you really need to see a graph. So you take your calculator and you go to y equals and you type this in. Once it's graphed, it will look like the graph on the screen because I did it earlier. Now, intervals of increase and decrease only use x values. So it's basically like you're doing the domain of one side and the domain of the other. Okay, let me say that again. Pay attention and focus. Intervals of increase and decrease only use the x values. So it's basically like the domain, but the domain of the increasing side, the domain of the decreasing side. Now, if you're going left or right, say there's a person walking up this hill. Well, I just gave it away. They have to walk up the hill first, correct? So that's the side that is increasing, because first they're walking up the hill. When did they start walking up the hill? Negative infinity, because since we're doing x values, this is to the left, which is negative, and then infinity. Then when they get up the hill, isn't this where they stop increasing? And that occurred at an x value of 3. Doesn't it look like 3? No, look. 1, 2, 3. Okay, so it increased from negative infinity until they got to 3. Because remember, you only use x values. So it's like the domain of the increasing side and now the domain of the decreasing side. If 3 is where it stopped increasing, isn't that because that's where it started to decrease? And then it decreases forever to the right, because x values, we only care about left or right, and it does that forever, so positive infinity. And then they are responsible for doing the other two. You have to do a little sketch if you don't have your own graphing calculator, but this is not that hard. What does this x minus 2 do to the parabola? What does this x minus 2 do to the parabola? It's with the x, and x goes left and right, so right 2. Okay, stop for a second. The formula is y equals a times x minus h squared plus k. So in the a place, they plugged in the 3. In the h place, they plugged in a positive 2. The minus was already there from the formula. So the h is a positive 2, which is why you go right 2. And then in the k place, they plugged in a positive 5. This 2 is not negative. That is already there from the formula. The 2 that was plugged in for h was a positive 2, which is why you go right 2. Plus, remember back when I taught this, I told you, the horizontal shift will go against your common sense. Minus 2 will shift it right 2, plus 2 will shift it left 2. And then plus 5 means up 5. So if you go right 2 and up 5 and plot your vertex, now which way will the parabola open, up or down? Up, because your a value is a positive number. If your a value is positive, it will open up. Now, the 3 will cause a vertical stretch, but that will not affect any of these answers. So you don't really have to worry about how skinny or wide to make it. So now, what is the domain? Correct. That's what the domain is for all parabolas. What is the range? No, this is positive 5 because it shifted up 5. Its lowest y value occurs at positive 5, and then from there it goes up forever. Where is the vertex? 2, 5. Is that vertex a max or a min? Right. Anytime the parabola opens up, the vertex will be at the bottom, which is a minimum. Where would you have to draw the axis of symmetry to cut it in half? X equals 2. Okay, which side is the parabola increasing? The left or the right? You're telling me this way is increasing? This way is increasing, and it started increasing right here at an x value of 2. It increased forever to the right, so positive infinity. Okay, then it decreased from negative infinity until it got to the vertex at 2. I mean, I guess not, but some people are visual and seeing the picture helps. Okay? I mean, like, yeah, you'll have the same number in opposite locations, and then you'll have infinities, but one will be positive, one will be negative, according to how the parabola opens. Now, in behavior, as x approaches negative infinity, what does that mean in one word? Left. And as it goes left, the y's are going positive infinity because they're going up forever. What does x approaches positive infinity mean in one word? Right. And what's the graph doing as it's going right? Positive infinity. Right, right. Okay, now turning your package to the next page, 13. Y equals a times x minus h squared plus k. Don't write this, just watch. That is called vertex form. The reason it's called vertex form is because when you look at that, you're able to easily identify the vertex. The vertex is the h and the k value. Now, y equals ax squared plus bx plus c is standard form. Remember last week how they gave us equations that were already in vertex form, like something like y equals x minus 2 squared plus 3, and you learned how to rewrite this into standard? Okay, let's practice that. What would I do first? Well, no, this is our, okay, you can. A is what? A is what? H is? And K is 3. Okay, so this is squared, so it means you write it twice. Okay, now what do I do with that? Hold on, Zach. Okay, so we need to multiply these together by distributing them. X times x and x times negative 2 will become x squared minus 2x. And then you need to distribute this, negative 2x, and negative 2 times negative 2 will become negative 2x plus 4, and then don't forget about the plus 3. Now all you have to do is combine like terms, so x squared minus 4x plus 7, is it now in standard form? What's the a? Just like before. What's the b? And what's the c? 7. So that's what we learned last week. We learned how to go from vertex to standard. So today, we're going to learn the opposite. We're going to be given the formula in standard, and we're going to take it to vertex. Now, believe it or not, this way is even more complicated. So, I am going to teach you a shortcut method. If you have a graph, look, if you have a graph, it becomes very easy. And think about it. You're going to have a graphing calculator, so even if they don't give you a picture with the equation, can't you type that in and make yourself a picture? So watch how to do it. What is the a value? What is the b value? And what is the c value? 8. So when we're writing it in vertex form, what do I plug in for the a place? 1. And then it'll be x minus h squared plus k. But h and k are the vertex. Where is the vertex located? Negative 2, comma 4. So think about it. The formula is x minus h. Well, what is your h value? Negative 2. The first number is the h, the second number is the k on the vertex. So if you take this negative 2 and substitute it in for the h, what happens right there? Right. That's why even though we went left 2, it ends up being x plus 2 in there. And then the k being a positive 4 means plus 4. Okay, now, in addition to doing that, we're going to practice everything we've been learning. Domain, range, y-intercept, axis of symmetry, interval of increase, interval of decrease, and end behavior. So write all of these things down and then we'll answer them together. Okay, what is the domain of this quadratic function? Correct. That's what it is for any parabola, correct? Because any parabola, whether it opens up or down, will still go left forever and right forever. So all parabolas have a domain of all real numbers. The range changes from parabola to parabola according to where the vertex is. The vertex is where? Okay, and which number do we need to use for the range? The 4, the y value. So it goes from 4, that's its lowest point, and then from there it only goes up forever, so to infinity. What is the y-intercept? 0, 8, because that's where it crosses the y-axis. Where would I need to draw in the axis of symmetry to cut it in half? What would be the entire equation, though? X equals negative 2, because it's an equation of a line. So the line, a vertical line starts with x equals instead of y equals. And since it's a vertical line that cuts through the x-axis at negative 2, you put x equals negative 2. Which side of this parabola is the increasing side? The right. When did it start increasing? Okay, intervals of increase and decrease only use x values. So when did it start increasing? And increase forever. So when did it start decreasing? And decrease until it got to negative 2. And then no matter which way you go on the parabola, to the left or to the right, both y's approach what? Positive infinity. Because parabolas behave the same way. Both ends go up or both ends go down. It's even because they behave the same. Okay, let's do number 2. Yes, but like, it won't be one problem where you have to do all that. It might give you a graph and say, what's the domain? And then the next problem might give you another one and say, what's the range? It'll be split up. Okay, number 2. What is the A value? 1. What's the B value? And what's the C value? 3. The first thing we need to do is rewrite that into vertex form. Remember, vertex form is y equals A. And what do I put in the A place? Parenthesis x minus h squared, parenthesis, plus k. But how do I figure out this h and this k? The vertex. What is the vertex location? 2, negative 1. And that's the h value, that's the k value. So if I take the h of 2 and plug it in right there, even though we went right, it ends up x minus 2, because the formula already had the minus. And then we go down 1, which is minus 1. Now, say that on the test you are taking one from standard to vertex form. Once you're done, how can you check and make sure you have it right? Graph both of them and make sure it makes the same parabola. So like for you, if you've typed in 2 equations in the y equals page and only one parabola shows up, that means that they're on top of each other and you've done it right. Okay, now let's do all the characteristics. Domain, range, y-intercept, axis of symmetry, interval of increase, interval of decrease, and then end behavior. Okay, for any quadratic function, what is the domain? Negative infinity to positive infinity. Okay, for this quadratic function, what is its range? -1 to infinity, because -1 is the lowest point it goes on the y-axis, and then from there it goes up forever. What is the y-intercept? 0, 3. Now let me quickly show you something about that. Where was the y-intercept in number 1? Where was the y-intercept in number 2? The c value is your y-intercept. Okay, the c value is your y-intercept. So that way if you're looking at a graph and you don't actually see it cross the y-axis, you can just look at the c value and know where it will cross. Okay, where's the axis of symmetry for this one? X equals what? 2. Okay, which side is increasing? The right side. When did it start increasing? 2, because we only care about x values for intervals. And then it quit increasing where? Well, how long did it increase? Positive infinity. And then when did it decrease? Until 2. And then no matter which way you travel, left or right, the parabola goes up for both because it opens up. Okay, try number 3 by yourself before I go. What did you get for the domain? What did you get for domain? Okay. What did you get for range? -2 to infinity. What is the y-intercept even though we can't see it on here? 0, 14. What is the axis of symmetry? X equals -4. Gosh. Okay. Interval of increase. Which side of the parabola is increasing? The right side. When did it begin increasing? At -4 is the x value. And then when did it quit increasing? Or when did it increase still? Hold on. Hello? Okay. Okay, decrease. What is the interval of decrease? Natalie, you're checking out. Right. And then both y's approach what? Oh, and then I forgot to do the actual standard to vertex form. What is the A value? What's the B value? 8. What's the C value? 14. We already found the X value of the vertex. It was -4. What's the Y value of the vertex? Negative. Oh, sorry. I meant to write 2. Guys, y'all got to be quiet. I'm trying to teach. Okay, so the A value is 1, so it's still 1 in vertex form. If I plug in this H value of -4, what happens right there? It becomes a +4. Make sure you figure out what the homework is, because there's homework. Okay, and then what's the K? So -2. All right, number 4. Yeah? At times, yes. What's the A value? 1. What's the B value? What's the C value? Okay, so when we write this in vertex form, A is still 1. So now I just need to figure out what the H and K are, which is the vertex, so I can fill that in. Where is the vertex? -3, 4. So if you plug in a -3 right here, won't it become a minus a negative, which is a +3? So are y'all starting to catch on why this is the opposite of what you would think? And then +4 is +4. Okay, now for the domain. The domain is negative to positive infinity. The range is 4 to infinity. The y-intercept is what? 0, 13. The axis of symmetry would be drawn where? X equals -3. The interval of increase only cares about what values? And so it starts increasing at and continues increasing forever. It started decreasing at negative infinity. It started decreasing somewhere over here and decreased until it got to -3. Those will always be in opposite locations too. So if the -3 is on this side, it's going to be on the other side for the other one, okay? And then as x approaches positive infinity, y approaches, that should say negative, positive, and then as x approaches positive infinity, y approaches positive infinity. Okay, now go to page 15. No, we're not done. We're behind. 15. Okay, number 1 on page 15. Identify the vertex. When you just are given an equation, what's the easiest way to identify the vertex of it? But this is not in vertex form, it's in standard. So what do you got to do? But there's no graph. Graph it on the calculator. Okay, so graph it on the calculator. Y equals x squared plus 16x plus 64. And then where is the vertex of that parabola? -8 is the x value of it, which is also called the h, and then 0 is the y value, which is your k. So the vertex is at -8, 0. Because to get to it, didn't you just go left 8 and then not up or down? So that is the h and k. So the vertex form would be y equals, what goes in the a place? 1, because that's the a value. And then x minus a -8 would be x plus 8 squared, and then plus 0, which you don't have to write. Okay, so now let's try number 2. We're going to identify the vertex and then write it in vertex form. So first graph it. Y equals 2x squared minus 4x minus 2 okay, it's over 1 down what? And if you're not sure about that, can't you just go to the table and confirm that there's a point that says +1, -4? And when you look at that, look around it. Around the -1, 4, oh, wait a minute. It's +1, 4. Okay, +1, 4. Look around that. -2, -2, 4, 4, 14, 14. See all the repeaters around it? That's the symmetric points on the parabola. So your vertex is 1, -4. So in vertex form, what goes in the a place? 2, because that's the a value. And then x minus squared minus 4. All right, number 3. Graph it and find the vertex. Okay, where does the vertex appear to be? Okay, I'm going to go to my table and confirm that there is a point 96 on this graph. Well, I'm just showing y'all exactly what you should be doing when you work these or take these tests. Okay, there is right there 96. So 9 is the h value, 6 is the k value. What is the a value? -1. And so parentheses, x minus the h of 9 squared plus the k of 6. Your homework is page 14. And you'd have to do exactly what we did on page 13. All of it. Okay, you have to write it in vertex form and list all the characteristics to get the stamp. It only takes y'all about 2 minutes per problem. So this is 12 minutes is what it should take.